Suppose for a moment that you could gaze into the heavens and see two suns instead of one. I invite you to delve into the enigma of binary stars, which are systems where a pair of luminous bodies revolve around each other, profoundly affecting planetary orbits, the potential for life, and the very appearance of the sky. Considering that more than half of all stars in the cosmos have a partner, this means our exploration takes us through a universe where stellar solitude is actually the exception, not the rule. Binary stars are defined as systems made up of two stars that orbit a shared center of mass. You can visualize them as two dancers gracefully moving across a cosmic stage, held in perfect sync by an invisible force that dictates their every step. This powerful gravitational bond is not just a beautiful sight. It is also essential to our comprehension of how the cosmos evolves, making their study crucial for astronomy, as we seek to understand how the universe operates. One of the primary reasons binary stars are so vital is that they function as natural cosmic laboratories. By observing their interactions, astronomers can unlock secrets regarding the mass, age, and chemical makeup of stars, which would otherwise be impossible to determine. The influence they have on one another is profound. Each time one star swings close to its companion, it causes measurable changes that provide a wealth of hidden information for scientists to analyze. Classifying binary stars is as varied as the instruments in a symphony orchestra, ranging from visual systems that you could observe directly with a telescope to others that demand sophisticated tools to detect their eclipses or spectroscopic signatures. Have you ever considered how many of the bright points of light in the night sky are not single stars but stellar pairs? The formation of these cosmic duos is a captivating process, originating from vast clouds of gas and dust that collapse under their own gravity, much like a ball of dough being squeezed into a denser form. It is truly fascinating how the life cycle of binary stars can diverge so sharply from that of their solitary counterparts. While a single star follows a relatively predictable path, the gravitational interactions within a binary system can radically alter that trajectory. The distance separating the two stars is a critical factor in their relationship. They can be so close that their gravitational pull is immense, or so far apart that their influence is far more subtle, with gravity acting as the ultimate conductor of their cosmic performance. This universal force of gravity molds the existence of binary stars in ways that are difficult to fathom, often triggering extraordinary phenomena. For instance, these powerful gravitational forces can lead to the transfer of mass from one star to its companion. This exchange can, in turn, result in the birth of new stars, or even trigger spectacular supernova explosions, which are cataclysmic events that leave a permanent mark on the history of the universe. Furthermore, binary stars serve a fundamental purpose in the field of cosmology. Astronomers use these stellar pairs as cosmic beacons to measure vast distances, which helps us better grasp the rate at which the universe is expanding. It may seem remarkable that two relatively simple stars can help us piece together the grand structure of the cosmos, but the secret is found in the precise mathematical relationship between their observable characteristics. Another compelling aspect of their study involves the methods for calculating their masses. By applying the laws of gravity to their orbital motions, scientists can determine the mass of each star in the system with incredible accuracy. This knowledge is foundational to astrophysics because a star's mass is the single most important factor dictating its entire life story, from its fiery birth to its ultimate destiny, hiding countless stories within those defining numbers. Exploring the relationship between binary stars and what are known as variable stars reveals an intriguing connection. Certain binary systems display regular fluctuations in brightness, which are caused by eclipses that happen when one star passes in front of its partner from our point of view. It's an amazing thought that these celestial games of hide and seek, creating a kind of cosmic light show, can teach us so much about the fundamental nature of stars and their physical properties. Supernovae represent another astonishing outcome of binary star interactions. When one star in a pair exhausts its fuel and reaches the end of its life, it has the potential to explode in a brilliant supernova that sends powerful shock waves rippling through space. This violent event not only signifies the death of a star, but also forges and distributes new, heavier elements throughout the universe, demonstrating how the demise of one star can seed the creation of others. Binary stars can also exert a significant influence on the development of planetary systems, as planets forming within the chaotic gravitational environment of a binary pair may be forced into highly unusual orbits. Just how many worlds might exist in the complex gravitational dance between these twin suns? The answer could fundamentally reshape our theories on planet formation and our understanding of where life might be possible in other systems. Ultimately, this journey into the domain of binary stars brings us to a crucial realization about the future of this research. With the advent of new technologies and more advanced observational techniques, astronomers are only just beginning to appreciate the full scope of what these systems can teach us. Our innate human curiosity, combined with a deep desire to comprehend our place in the cosmos, guarantees that the exploration of binary stars will continue to astonish and inspire us for decades to come. Across the vastness of the cosmos, you can find the remarkable phenomenon of binary stars. So, what are they, precisely? In its simplest form, a binary star is a system where two stars are gravitationally bound, orbiting a shared center of mass. But I urge you not to be misled by that simple description, as it barely scratches the surface. You might picture two dancers moving in flawless synchrony on a cosmic stage, their distinct styles blending into a harmonious performance. This is the essence of how binary stars behave. Now, let's explore how these stellar pairs are classified, because this is where the subject becomes truly compelling. I can tell you there are several kinds of binary systems, typically categorized as visual, spectroscopic, and eclipsing. In a visual system, both stars are luminous enough that you can distinguish them separately from Earth, much like observing two friends in a park and noting how they move around each other. Spectroscopic systems, however, involve stars so close together that they can only be identified by analyzing their distinct light spectra, similar to how you can discern two different voices in a lively discussion without actually seeing who is speaking. Finally, you have eclipsing systems, which are oriented in such a way that, from our viewpoint, one star periodically passes in front of the other, dimming its light. You can imagine a shadow play, where one silhouette momentarily obscures the glow of another. Each of these binary star types presents its own unique set of characteristics and behaviors, which only adds to their captivating nature. But this brings up a fundamental question. How do these extraordinary systems even come into existence? The creation of binary stars takes place within immense clouds of interstellar gas and dust. As these cosmic clouds collapse under their own gravity, they can fragment into two or more dense cores, with each one eventually igniting to become a star. You can visualize it as two soap bubbles forming from the same pool of liquid, and then merging. These stars are born of the same fundamental material, and often share a connected destiny. Indeed, the life story of binary stars is another fascinating chapter. Unlike solitary stars that chart their own evolutionary course, the stars within a binary pair profoundly shape each other's life cycles. For instance, if one star swells into a red giant, its partner is bound to undergo dramatic shifts in its own development. It is almost as if one companion provides the other with a glimpse into its own cosmic future. In certain scenarios, the stars might even spiral into one another and merge, forging a single, more massive, and brilliantly luminous star. When we examine the spacing of these stars, we can classify them as either close or distant binary systems. In close systems, the stars are so near that their powerful mutual gravity dictates their behavior, much like two friends holding on to each other during a wild roller coaster ride, where their motions are completely intertwined. In contrast, stars in distant systems are more like casual acquaintances you might see in your neighborhood. They inhabit the same general area, but their lives do not deeply intersect. So, let me elaborate on how gravity shapes the dynamics of these stars. Gravity acts as the invisible tether connecting the two stars in a binary pair, and the closer they are, the more powerful this connection becomes. This powerful interaction can trigger some astonishing phenomena, including the transfer of mass from one star to its companion. If one star is substantially larger, it can siphon material away from its partner, causing brilliant flare-ups and dramatic fluctuations in brightness, as though one star is borrowing the other's energy to shine more intensely. Binary stars offer you more than just a celestial spectacle. They serve a crucial function in the field of cosmology. Because of their predictable orbital mechanics, I can explain that astronomers use these systems to gauge distances across the universe. By observing a binary star, we can calculate its mass, which in turn allows us to determine how far away it is. In this way, they function like a cosmic measuring stick, helping us to map the immense scale and structure of space. Let's touch upon how we actually measure the masses within these systems. Astronomers employ some truly clever techniques to ascertain the mass of each star in a binary pair. Through meticulous observation of their orbital motions, scientists can apply fundamental laws of physics to precisely calculate their individual masses. I must stress that this information is vital, not just for comprehending binary stars themselves, but for understanding a wide range of other astrophysical events as well. The phenomenon of variable stars is also interestingly linked to binary systems. When you have a binary system where one star periodically crosses in front of its companion from our line of sight, you will observe distinct changes in brightness. This event is what we call an eclipse, where the light from one star is momentarily obstructed. These occurrences are not merely visually stunning. They present scientists with invaluable chances to analyze the composition and behavior of the stars involved. However, I want you to understand that binary stars are much more than a beautiful sight in the night sky. They can also be the source of cataclysmic events like supernovae. You might wonder how this is possible. In some cases, one of the stars in a binary system can accumulate a critical amount of material from its partner, which triggers a thermonuclear explosion that blazes across the universe in a breathtaking display. These explosions are not only awe-inspiring, but also play a fundamental role in forging the heavy elements that constitute the world around us. The influence of binary stars even reaches into the realm of planetary formation. Within a binary system, the gravitational pull of two stars can disrupt the stability of the protoplanetary disk, where planets might otherwise form. This introduces fascinating questions about whether planets can even arise in such dynamic environments, and what unique properties they might possess if they do. You can see how these systems challenge our very understanding of how worlds are born. Finally, we have to consider binary systems that feature compact objects like neutron stars and black holes. I find these systems especially compelling because they showcase some of the most extreme physical phenomena in the entire universe. The interplay between these incredibly dense objects and their stellar companions can generate intense radiation and cosmic events that push the boundaries of our current comprehension of physics. In closing, I hope you see that binary stars are far more than just pairs of bright dots in the sky. They are intricate, interconnected systems that provide us with a spectacular window into the fundamental nature of the cosmos. As we continue to investigate these systems, we uncover not only the sheer beauty of astronomy, but also profound truths about the cycles of life and death that governs the universe. Binary stars can be seen as cosmic partners, locked in a perpetual dance that spans the immense expanse of the universe. But have you ever wondered how these captivating celestial pairings come into being? The journey of a binary system originates within the vast clouds of gas and dust scattered throughout space, which we call nebulae. Inside these enormous stellar nurseries, gravity asserts its influence, causing a section of the nebula to condense and collapse under its own weight, giving rise to a protostar. However, this nascent star is often not born in isolation. Frequently, two or more protostars emerge almost simultaneously, establishing a binary connection from the very beginning. Picture two companions embarking on a journey down the same trail. If their pace and direction are perfectly matched, their paths naturally weave together in a harmonious dance. And this is precisely how the shared life of binary stars commences. As they coalesce, their mutual gravitational pull binds them together, creating a system where they can mutually influence and shape one another. But what if one star accumulates more mass than its partner? Such an imbalance can disrupt their equilibrium, paving the way for unforeseen and complex interactions. As these stellar bodies mature and evolve, they ignite nuclear fusion in their cores, a critical process that powers their luminosity and ensures their stability. Yet, much like any long-term relationship, the developmental path of each star can vary significantly. One might burn through its nuclear fuel at a much faster rate than its counterpart, introducing a form of celestial rivalry. You could witness a scenario where one star has already expanded into a red giant, while its companion continues to shine brightly as a main sequence star. The formation of these stellar pairs can also occur through encounters between stars that are already fully formed. Occasionally, a lone star can gravitationally capture another that happens to pass nearby, forging a new cosmic bond in a process that is not at all uncommon in the universe. Just as we might form new friendships through chance encounters in our own lives, stars can also find companions in the most unexpected ways. Once a binary system is formed, it embarks on its own unique story, with the two stars orbiting each other in a magnificent celestial display. But did you know that the distance separating them can be incredibly varied? Some pairs are so close that their evolutions are deeply intertwined, while others are separated by light years, maintaining a much more distant, though still connected, relationship. Their shared existence is far from a simple romantic journey. It is a dynamic saga filled with dramatic turns. When one star in a binary system evolves into a red giant, it may begin to shed mass, which is then drawn toward its companion. This phenomenon, referred to as mass transfer, is pivotal for understanding the evolutionary trajectory of both stars. The consequences of this exchange can be profound, sometimes culminating in a supernova explosion, where one star vanishes in a brilliant burst of light, leaving its partner to drift through space alone. Investigating the formation of these systems isn't just vital for comprehending the life cycles of stars. It also helps us unlock the greater secrets of the cosmos. These stellar duos provide astronomers with invaluable tools for measuring cosmic distances and calculating stellar masses. Through observing their interactions, scientists can deduce a great deal about the galactic environments they inhabit and the cosmic history they have shared. This raises a fascinating question. Can binary stars affect the formation of planets? The answer is a definitive yes. A pair of stars can significantly alter the dynamics of any surrounding disk of gas and dust, thereby influencing how and where planets might form. In some scenarios, planets can end up orbiting just one of the stars, or even both, resulting in a truly unique planetary system. The life of a binary system doesn't conclude when one of its members depletes its fuel. The ongoing interplay between the stars can give rise to spectacular phenomena, including the formation of black holes or neutron stars. These events provide us with compelling narratives about the ultimate fate of stars and the legacy they leave behind in the universe. From their birth in nebulae to their intricate evolution and the influence they exert on their surroundings, binary stars offer an incredible window into the dynamics of the cosmos. Much like the relationships in our own lives can have enduring impacts, these stellar partnerships shape the universe in wonderful and remarkable ways. The creation of a binary system is merely the prologue to an extraordinary journey through space and time, where every interaction and every transformation contributes to a richer understanding of the cosmos. These cosmic pairs, like us, have stories to tell, and each new discovery about them brings us closer to unraveling the deepest mysteries of our universe. The captivating dance of binary stars serves as a powerful reminder that even in the vastness of space, nothing is ever truly alone. When two stars decide to merge in this cosmic performance, their lives become a story of amazing and complex interactions, rather than simple coexistence. In many cases, their evolution is a narrative of cooperation, competition, and occasionally, cataclysmic explosions. The saga of a binary star begins with two stars born from the same interstellar cloud of gas and dust. You can imagine a cosmic nursery where two stellar twins are formed, each with distinct traits but forever linked by gravity. As they mature, their relationship grows more complex, pulling on each other as they orbit a common center, like two dancers on a celestial stage moving to a rhythm only they can perceive. As you observe their evolution, you'll notice that binary stars can have destinies that are profoundly different from those of solitary stars. The exchange of matter between them is a common occurrence, a transfer of material that could be likened to friends sharing gifts. But what happens when one star is significantly larger than the other? The more massive star can actually pull material away from its companion, a dynamic you could compare to an older sibling who always claims the best toys. This process of mass transfer can trigger dramatic shifts in the lives of both stars, causing one to shed its mass and transform into a red giant, while the other experiences a surge in brightness and temperature, charting a completely unique life cycle. In the immense expanse of the universe that envelops us, stars can gather in numerous ways. But today we will explore one of the most compelling arrangements: binary stars. Have you considered that not every star you see travels the cosmos alone? Many exist in stellar systems composed of two stars locked in a mutual orbit. This arrangement is more than just a cosmic curiosity. It unlocks a world of interactions and dynamics that continually challenges our comprehension of the universe. Binary stars are generally categorized into two main groups: close and distant systems. But what truly distinguishes them? You can picture it like a dance floor. Close binaries are like two partners moving together in a tight, intimate space, whereas distant binaries are dancers who, while sharing the same floor, maintain a considerable space between them. This proximity, or lack thereof, fundamentally dictates how they interact and evolve throughout their existence. When you consider close binary stars, their gravitational pull on each other is significantly more powerful. These systems can be so near that one star actively siphons material from its partner in a process known as mass transfer. This exchange can trigger sudden and dramatic transformations in the lives of both stars. Imagine having a companion so close that their influence reshapes your very being. That is the nature of the bond between these stars, a perpetual dance of attraction and repulsion. On the other hand, distant binary stars do not exert such a powerful influence on one another, yet they remain bound within a fascinating system. You might think of them as good friends who connect periodically, sharing their journeys without being deeply entangled in each other's daily lives. Nonetheless, their shared existence within a single system still shapes their evolution, as the gravity from one star can alter the other's trajectory over vast timescales. As the journey of a binary star system progresses, its evolution can become far more dramatic. When the stars draw nearer, they have the potential to merge, forging a single superstar. Think of two water droplets coalescing into one, but on a scale with truly astonishing results. Such a merger can trigger cataclysmic phenomena, including supernova explosions that release enough energy to momentarily outshine their entire home galaxy. However, a spectacular explosion is not the inevitable conclusion for all binary stars. Some pairs, after navigating long and intricate histories, are destined to become white dwarfs. This is a fate where the stars transform into incredibly dense and cold celestial bodies, leaving behind faint imprints of their former existence. In this way, binary stars demonstrate that life can follow many different trajectories, and every choice these stars make profoundly shapes their destiny. Furthermore, binary stars provide astronomers with a unique opportunity to better grasp how stars function and originate. By studying these pairs, scientists can deduce the mass, composition, and temperature of the stars with a precision that would be much more difficult to achieve if they were isolated. Consequently, every binary system acts as a cosmic laboratory, enabling experiments and observations that would otherwise be beyond our reach. The comparison between binary and solitary stars is truly captivating. While a lone star embarks on an individual journey through the cosmos, binary stars are bound by a shared destiny. The perpetual interaction between them offers a distinct advantage for studying the fundamental forces that sculpt the universe. This cooperative dynamic serves as a reminder that unity often yields strength, even in the vast and solitary expanse of space. Considering all this, it is natural to wonder how binary stars influence the creation of planetary systems. Within a binary environment, any planets must navigate a complex dance governed by the gravitational pull of two stars, which can make their formation and stability incredibly challenging. So, how do these planetary systems manage to endure amid the competing gravitational forces? The answer suggests that while it presents a formidable hurdle, life often finds a way, and some planets may indeed flourish. Ultimately, when you observe the life cycle of binary stars, it is impossible not to be captivated by the sheer variety of their potential fates. From awe-inspiring explosions to the formation of complex planetary systems, each binary pair has a unique story to tell. As they reach the end of their lives, these stars leave an indelible mark on the cosmos, whether as raw material for new stars or as fascinating celestial remnants, reminding us that the universe is brimming with wonders and surprises. Think of a binary star system as more than just two distant points of light. Picture yourself at a park, observing two friends tossing a ball back and forth, constantly moving and circling each other. This dynamic is a perfect analogy for the relationship between binary stars, where the fundamental force of gravity acts as the unbreakable tether that locks them in a perpetual, captivating dance. The same gravitational force that anchors planets to the sun governs the interactions within these stellar pairs. Should one star venture too close to its partner, it can begin siphoning material away, sparking an energetic and sometimes volatile cosmic exchange that can lead to massive explosions. Their relationship is a delicate equilibrium, reminiscent of a couple that needs to find harmony to coexist. If one partner's gravitational pull becomes too dominant, its companion can be seriously compromised. Gravity, therefore, doesn't just dictate their movement. It is the ultimate arbiter of their stability. Consider a child on a swing who pushes too high and risks falling. Similarly, if the gravitational bond isn't perfectly calibrated, the stars could fly apart, shattering their systemic balance. This force is both the chain that links them and the governor that keeps their celestial waltz in motion. While these stars revolve around a common center, their mutual gravity generates immense tides of gas and dust, pulling this material toward one of the partners. This effect is analogous to how our moon influences Earth's oceans, but on a cosmic scale, with interstellar gas instead of water. As this gas accumulates and accelerates towards the star, it heats up and can form a brilliant glowing structure known as an accretion disk, encircling the more massive of the two. It's rare for stars in a binary pair to have identical masses, and this disparity can result in extraordinary circumstances. When one star is substantially larger, it can trap its smaller companion in a cycle of consumption, establishing itself as the dominant force in the system. This gravitational interplay of mass and power can trigger a range of spectacular events, from the birth of exceptionally luminous stars to cataclysmic supernova detonations. The orbital velocity of these stars is also a function of gravity. Just as some objects spin more rapidly than others, a star in a binary system moves faster the closer it is to its partner. You can visualize this as two dancers who quicken their pace as they draw nearer to one another on the dance floor. Even a slight shift in their distance from each other can dramatically change the tempo of their entire cosmic performance. An even dramatic scenario unfolds when one of the stars exhausts its fuel and nears the end of its existence. In this final act, gravity can deal a truly astonishing hand. If the dying star explodes as a supernova, the blast will have unforeseen consequences for its companion, reshaping the local environment and potentially seeding the cosmos with the raw materials needed to form entirely new stellar systems. The formation of black holes is another area where binary systems are critically important. If one member of the pair collapses into a black hole, the surviving star becomes trapped in a perilous dance, orbiting a partner that has transformed into an invisible gravitational singularity. This outcome demonstrates how gravity can reshape the familiar into the profoundly alien, pushing the limits of our cosmic comprehension. Beyond their own dynamics, binary stars are pivotal in the creation of planetary systems. Just imagine what it would be like to inhabit a world with two suns in its sky, a setting that would foster extraordinary conditions for life. The combined gravitational pull from both stars would influence everything from a planet's initial formation to its long-term climate, potentially sculpting a truly unique and even habitable world. Furthermore, these systems provide us with invaluable natural laboratories for investigating physics at its most extreme. In pairs that feature a neutron star or a black hole, the gravitational forces are so intense that they strain the very fabric of our current physical theories. Studying these environments allows us to probe the absolute frontiers of our knowledge about how the universe operates. As our research into binary stars deepens, we find they may hold clues to one of the biggest mysteries in cosmology: dark energy. Indeed, astronomers can leverage certain types of binary systems to measure vast distances across space. These measurements are crucial for mapping the expansion of the cosmos and helping us understand the enigmatic force that appears to be speeding it up. In the end, binary stars are far more than simple points of interest in the night sky. They represent essential components in solving the grand puzzle of the universe, from its origins to its ultimate fate. So the next time you gaze upward, try to see beyond their shimmering light and imagine the epic sagas of connection, conflict, and change playing out over eons. This celestial dance is a magnificent spectacle that rightfully continues to captivate both professional astronomers and casual stargazers alike. As you gaze into the night sky, you see countless points of light, but many of them conceal a deeper and more enigmatic phenomenon: binary stars. What are these paired stars, and what makes them so crucial to the field of astronomy? They are far more than just twin lights in the celestial darkness. They represent a fundamental astronomical occurrence that offers profound insights into the universe itself. So, what is it that makes these stellar pairs so significant? Binary stars provide us with essential clues regarding the formation and evolution of entire galaxies, and they even help us probe the fundamental nature of the cosmos. By carefully observing their interactions, astronomers can accurately measure cosmic distances and calculate stellar masses, which are indispensable steps in solving the universe's greatest puzzles. One of the most compelling questions is how these systems allow us to measure the cosmos. Picture yourself standing in an immense dark field with just two lit beacons. If you know the exact distance between those beacons and their individual brightness, you can determine your position relative to other points in that field. In much the same way, binary stars serve as cosmic lighthouses, guiding us across the vast distances of space, enabling scientists to map out not just their location, but also their mass and chemical makeup. Another captivating aspect is the profound influence that binary stars exert on the evolution of their host galaxies. Have you ever considered how a pair of objects could shape its entire environment? Through their powerful gravitational dance, these stars can redirect the formation of new stars and even affect the distribution of the invisible dark matter that envelops them. Each binary system, therefore, acts as a miniature, self-contained laboratory, revealing the secrets of cosmic architecture. These stellar pairs are also vital for our quest to understand dark energy. To grasp what dark energy is, imagine the universe as a bubble that is perpetually expanding. Dark energy is the force causing this expansion to accelerate. By studying the gravitational interplay within binary star systems across the cosmos, scientists can observe the behavior of the universe on a grand scale and gather clues about this mysterious energy, which constitutes a vast majority of everything that exists. The evolutionary path of binary stars is another area of intense study, as their shared existence leads to some extraordinary outcomes. When two stars are gravitationally bound, their life cycles become intricately connected. As they age, they can undergo dramatic events, including mergers where one star consumes its companion, unleashing a colossal burst of energy. Such an event not only seals the fate of the stars involved, but also radically transforms their cosmic neighborhood. In this context, binary systems also offer a unique perspective on cataclysmic events like supernovae. Did you know that some of the most luminous explosions ever witnessed originate from binary stars? When one star in a pair evolves into a red giant, it can begin transferring its mass to its partner, which can trigger a titanic detonation. This process doesn't just light up the cosmos. It is also a primary mechanism for forging the heavy elements that eventually form planets like our own. Furthermore, the influence of these paired stars extends to the formation of planets. Within the swirling protoplanetary disks that surround young stars, the gravitational pull of a binary system can dramatically alter the dynamics. It's like a cosmic carousel, where the spinning stars affect the orbits of developing planets. This reality raises fascinating questions about the kinds of planetary systems that might form around two suns, and how they would differ from our own. Exploring these phenomena, Astronomers have also found that binary systems can harbor some of the most extreme objects in the universe, including neutron stars and black holes. These unique pairings provide an unparalleled opportunity to study physics under the most intense conditions imaginable. For instance, the collision of two neutron stars creates an awe-inspiring spectacle that pushes the very limits of our current understanding of physical laws. Binary stars also serve as a reflection of the Milky Way's long history, with each pair narrating a story of change and development over millions of years. Scientists have identified binary systems within our own galaxy that are critical to deciphering how stars initially formed and how they became distributed throughout space. This knowledge is essential for building a more complete picture of our own place in the universe. It's truly remarkable how modern technology has empowered scientists to observe and analyze these stars with a level of precision that was once unimaginable. Advanced telescopes and spectroscopic methods now allow us to peer deeper into space than ever before. As this technology continues to evolve, our understanding of binary stars and their cosmological role is certain to grow even more profound. Finally, it's important to correct a common misconception about binary stars. Many assume they are an unusual or rare occurrence, but the reality is that more than half of the stars in our galaxy are thought to exist in pairs or larger systems. This fact prompts us to reflect on the deep interconnectedness of the cosmos, where every star contributes to the magnificent celestial tapestry. Ultimately, gravity is the fundamental force that not only binds binary stars, but also weaves together the very structure of the cosmos. As we persist in our exploration of the universe, the study of these stellar pairs and their gravitational relationship will continue to be a rich source of knowledge. Each new discovery inches us closer to comprehending our own existence within this immense and mysterious universe. As the cosmic journey of binary stars continually reveals ancient secrets and reshapes our perception of reality. You might typically imagine stars as isolated points of light, but the reality is that a great number of them are paired with a stellar companion. In the fascinating realm of these binary stars, celestial bodies perform a gravitational ballet. Measuring their masses is a bit like a cosmic balancing act. By observing the motion of one star and applying Newton's law of universal gravitation, we can calculate the mass of the other. Astronomers primarily rely on two clever methods to accomplish this: observing radial velocity and analyzing the light curve. Radial velocity tracks a star's movement toward and away from Earth. As a star approaches, its light shifts toward the blue end of the spectrum, and as it recedes, it shifts toward the red. By precisely measuring these spectral shifts, scientists can determine the star's speed and, consequently, its mass. Alternatively, there is the light curve method. Consider a scenario where, from our perspective, one star in a binary system passes in front of its partner. During this eclipse, the total brightness we observe from the pair diminishes. By carefully tracking these changes in brightness over time, astronomers can deduce the mass of both stars, in addition to determining their size and the distance separating them. But you may wonder why it's so crucial to know the masses of these stars. Mass is the most fundamental property in astrophysics, as it governs the entire evolution of a star. For instance, more massive stars have life cycles that are significantly shorter and more dramatic compared to their lighter counterparts. Understanding these masses helps us map the cosmos and comprehend the intricate processes of star formation and evolution. Binary stars also play an essential role in calibrating the distance scale of the universe. By ascertaining the mass and brightness of a binary pair, astronomers can establish more accurate distances to other celestial objects. This technique is a vital part of figuring out the structure of the universe and measuring the rate of its expansion. When we study neutron stars and black holes, measuring mass becomes even more intriguing. After a massive star exhausts its fuel, it can collapse to form one of these incredibly dense objects. Within a binary system, their gravitational interactions are exceptionally intense, and measuring their mass not only reveals the nature of these stellar remnants, but also helps us understand extreme phenomena like the emission of gravitational waves. Variable stars also contribute significantly to these measurements. Some binary stars exhibit regular changes in brightness caused by eclipses, while others undergo pulsations. These fluctuations provide valuable clues about the mass and internal structure of the stars, serving as another powerful tool for astronomers. However, the work is not always straightforward, as the influence of gravity can lead to complex and unpredictable dynamics that complicate our measurements. Despite these challenges, each new finding about binary stars moves us one step closer to understanding the vast universe that envelops us. This research is not merely an academic exercise. It is a journey through the cosmos that helps us learn how everything works. From the motion of individual stars to the formation of entire galaxies, every discovery contributes another piece to the grand puzzle. Binary stars stand as silent witnesses to the history of the universe, and by studying their masses, we can begin to tell their stories. So the next time you look up at the starry sky, remember that there is much more to those twinkling lights than meets the eye. How can these stars alter their brightness so dramatically? What unfolds when two stars are positioned so closely together? It often seems as if they are performing a celestial waltz. In the vastness of the universe, some stars are not solitary travelers, but are instead accompanied by a companion, sharing their journey through space. When these stars align from our earthly perspective, so that one passes in front of the other, they can eclipse each other. This event is not only a visually stunning spectacle, but also a gateway to understanding the nature of these stars, as changes in their light reveal secrets about their size, composition, and distance. Imagine you are in a theater, and one of the performers moves behind a curtain, causing the light on stage to dim. This is precisely what happens in the sky when we observe the eclipse of a binary star. This cosmic interaction is more than just a beautiful display. It transforms into a powerful instrument for studying the fundamental properties of these stars. One of the most interesting aspects of binary stars is their ability to influence their surroundings. When one star in a pair evolves into a red giant and starts to expand, it can grow large enough to reach its companion. This encounter can be turbulent and dramatic, igniting a series of events that can result in astronomical phenomena such as supernova explosions. By analyzing these systems, scientists can better comprehend not only the lives of stars, but also how these interactions affect other celestial bodies in their galactic neighborhood. You can think of the relationship between binary stars as being similar to two close friends who share everything, where one, being more massive, often takes material from its partner. This phenomenon, known as mass transfer, can profoundly reshape the evolutionary trajectory of both stars. Much like a friend who always grabs the last slice of pizza, the larger star's influence can steer its companion down an entirely unforeseen developmental path, leading to the creation of some of the most exotic objects in the cosmos. Through careful observation of binary star systems, astronomers have made incredible breakthroughs in determining the mass of individual stars. This data is absolutely vital, because understanding a star's mass is the key to unlocking the secrets of its entire life cycle. Just as a person's weight can offer insights into their health, A star's mass reveals a great deal about how it will exist and eventually perish, and binary systems provide a unique chance to measure these masses with a precision unattainable for solitary stars. Binary stars also assume a critical role in the research of variable stars, which are stars whose brightness fluctuates over time. Many of these variations are not self-contained, but are actually caused by the intricate interactions between two celestial partners. For instance, when a star appears to dim, it might not just be running low on fuel. Its companion could be playing a significant part on this cosmic stage, creating a dynamic spectacle that teaches us about the complexities of stellar life. It's truly fascinating to consider how binary stars function as cosmic laboratories, allowing us to probe the universe's mechanics. By analyzing their patterns of brightness, scientists can classify different stellar types and gain a deeper understanding of their behavior. The question of how stars act when they are gravitationally bound in a binary system often yields surprising and revealing answers, enabling astronomers to continuously broaden their knowledge of the universe. It is also important to remember that the study of binary stars carries implications that reach far beyond the field of astronomy. By observing these stellar interactions, scientists can uncover clues related to dark energy and the expansion of the universe. The way these seemingly simple paired stars can help unravel the most profound mysteries of the cosmos lies in their direct influence on the structure and evolution of the universe itself. Across the night sky, binary systems stand as silent observers of the universe's long history, with each interaction and every burst of light narrating a story that has unfolded over millions of years. When we study these phenomena, we aren't just observing stars. We are gazing back through time at the very conditions that shaped our cosmos. The link between binary and variable stars serves as a beautiful reminder that the cosmic dance of light and shadow is perpetual. So, every time you gaze up at the sky, remember that behind each glimmer of light there is likely a story waiting to be told, one that reflects the immense complexity and wonder of the universe we call home. Binary stars are an open invitation for you to be curious, to ask questions, and to continue exploring the vast and magnificent cosmos that envelops us. Supernovae rank among the most breathtaking events in the entire universe, and when one occurs within a binary system, the spectacle becomes even more enthralling. But what exactly is a supernova, and what makes its occurrence in a binary pair so special? At its core, a supernova is the explosion of a very large star as it reaches the end of its life. But within a binary star context, this process can become vastly more intricate and stunning. As you know, binary stars are pairs of stars that orbit a common center of gravity. But in many cases, their masses are unequal, which means their evolutionary timelines do not sync up. Imagine a scenario where one star is significantly more massive than its companion. As this heavier star depletes its nuclear fuel, it starts to expand into a red giant. And it's at this point that the dynamics of the binary system grow truly intriguing, as the massive star can begin transferring its material to its partner. What happens when that massive star finally goes supernova? If it has managed to accumulate a sufficient amount of mass from its companion, the outcome can be a cataclysmic explosion that not only obliterates the massive star, but can also profoundly affect its neighbor. This blast can propel an enormous quantity of matter into space, enriching the interstellar medium with heavy elements and paving the way for the formation of new stars and planets. This raises the question of how we can determine if a binary star is destined to explode as a supernova. In general, two main types of supernovae are associated with binary systems. The first is a type Ia supernova, which takes place in a system composed of a white dwarf and a companion star. As the white dwarf siphons material from its partner, it eventually reaches a critical threshold called the Chandrasekhar limit and detonates in a brilliant flash. In contrast, Type II supernovae happen in systems where a massive star explodes after exhausting its fuel, and its presence in a binary system can make the event even more spectacular, sometimes causing an asymmetrical explosion that sends shockwaves through the galactic vicinity.
So, what are the ultimate consequences of a supernova erupting within a binary system? After the massive star explodes, its companion can be severely affected. If the explosion is close enough, the companion star might be bombarded with intense radiation, and, in some scenarios, could even have its atmosphere completely stripped away. However, it's not always a story of destruction. Sometimes, the companion star can endure the cataclysm and continue its life cycle, though its environment will have been permanently and dramatically altered. It is truly remarkable to think that these supernova explosions act as beacons of light across the immense expanse of the universe. They are not simply events that signify the end of a star's existence, but are also fundamental to the creation of new elements. The heavy elements forged during a supernova are in fact the very same elements that compose our bodies and everything in the world around you. In a way, whenever you gaze at the night sky, you are looking at the remnants of these immense cosmic detonations. The investigation of binary stars and their relationship to supernovae remains a highly active field of research, as astronomers use advanced telescopes and instruments to peer into these systems and solve the puzzles surrounding these powerful events. Every newly identified supernova offers fresh clues into the fundamental properties and life cycle of stars, deepening our comprehension of stellar evolution. These explosions do more than just enrich the interstellar medium with new elements. They can also serve as the catalyst for the birth of new stars. The resulting shockwave from a supernova can compress vast clouds of gas and dust, creating the necessary conditions for new generations of stars and planets to emerge. This process ensures that the cycle of stellar existence, powered by destruction, perpetually continues. Supernovae occurring in binary systems offer profound lessons about the mechanics of the universe, illustrating how the interplay between stars can trigger magnificent phenomena. These events highlight the deep and intricate connection between the life and death of stars, showing us a story of transformation, where a star's demise clears a path for new creation in the cosmos. Ultimately, supernovae in binary systems are a remarkable phenomenon that showcases the universe's complexity and elegance. Through these cosmic blasts, we witness not just the end of stars, but also the beginning of new worlds. With every supernova we analyze, we move a little closer to understanding our own position within this immense and enigmatic cosmos. Have you ever pictured two stars engaged in a celestial dance across the vastness of space? This is precisely what binary stars are, the outcome of an intricate cosmic ballet where two stars orbit a common center, much like a pair of dancers in flawless harmony. But what happens when these stellar partners exist in a region where planets are also being born? Let's delve into the compelling realm of planet formation within these dual star systems. It's vital to recognize that a binary star system is far more than just two stars drifting together. The presence of a companion star can profoundly alter the development of a planetary system. The gravitational pull of each star influences the other, which in turn reshapes the entire surrounding environment. A protoplanetary disk of gas and dust, the very birthplace of planets, forms around a young star. But this process becomes substantially more complex in a binary system. The gravitational influence of the second star can disrupt how material within this disk coalesces and grows, making the environment for planet formation far more turbulent. The distance separating the two stars is a crucial factor in this dynamic,
If the stars are sufficiently far from each other, each may host its own stable disk, enabling planets to form around them independently. If they are too close, however, their combined gravity can tear the disks apart, making planetary formation nearly impossible. The mechanics of these systems can also give rise to planets with highly unusual orbits, such as those with extremely elliptical paths or trajectories that weave between the two stars. This presents the incredible possibility of a world that experiences drastic shifts in light and temperature as it alternates between its two suns. Such variability would have a massive effect on the evolution of a planet's atmosphere and its potential to support life. Binary systems, therefore, act as natural laboratories for creating planets with extraordinary features, including those with highly eccentric orbits or locked-in complex orbital resonances. This brings up the critical question of whether such systems could ever harbor habitable worlds. Scientists speculate that, given the right distance and mass for the stars, stable habitable zones could exist. Still, the gravitational instability from the second star presents a significant challenge to maintaining the stable conditions necessary for life to emerge and flourish. As our study of these systems progresses, we are learning just how different planet formation in binary systems is compared to that around single stars like our Sun. Some research even indicates that binary systems might be more prevalent than we once believed, meaning countless planets could be orbiting paired stars. This potential for diversity challenges our conventional ideas about where life might exist, opening up a universe of new possibilities as we continue our exploration of the cosmos. The cosmos contains phenomena that might seem drawn from science fiction, yet they are entirely real. Among the most incredible are binary systems pairing neutron stars with black holes. To grasp how these exotic objects interact, you must first understand the life cycle of stars. Much like our own Sun, stars are born from immense clouds of interstellar gas and dust, and some are destined to live out their existence in pairs, forming what we know as binary systems. Picture one of the stars in such a pair eventually depleting its nuclear fuel, much like an engine sputtering to a halt after running out of gas. Its life culminates in a supernova, a colossal explosion that causes its core to collapse under its own gravity, leaving behind an incredibly dense object known as a neutron star. The density of a neutron star is so extreme that a single teaspoon of its matter would weigh millions of tons here on Earth. Within a binary system, gravity is the master choreographer of a profound cosmic dance. The two stars orbit a shared center of mass in the vast emptiness of space, and if they draw close enough, the powerful gravity of the neutron star can begin siphoning material away from its companion. This process, known as accretion, resembles one person trying to drink a milkshake while another continuously steals sips, causing the siphoned matter to heat up and radiate brilliantly. The dynamic becomes even more dramatic when one of the partners is a black hole, which forms when a star far more massive than the one that creates a neutron star dies in a similarly catastrophic explosion. In this scenario, the companion star is caught in a truly hazardous dance. A black hole's gravitational pull is so immense that nothing, not even light itself, can break free, causing matter from the companion to spiral inward, forming a superheated disk that unleashes tremendous amounts of energy. So, how can we be certain that these remarkable systems actually exist? The proof is found by carefully observing the universe. Using advanced telescopes and other astronomical instruments, we can detect the distinctive radiation signals these systems produce. For instance, as a neutron star or black hole pulls in matter, it emits powerful X-rays.
cosmic signals alerting us that an extraordinary event is taking place millions of light-years away. The story of these stellar pairings is more than just a breathtaking spectacle. It holds a crucial place in the evolution of the cosmos itself. When a neutron star or black hole gathers a sufficient amount of material from its partner, it can trigger a new supernova, blasting energy and heavy elements far into space. These very elements are the building blocks for new generations of stars and planets, making these exotic objects the architects of the universe, forging the raw materials for life itself. This brings us to the profound connection these systems have with Albert Einstein's theory of general relativity. When a black hole and a neutron star orbit one another, their immense mass warps the fabric of space-time so intensely that they generate gravitational waves. These waves are like ripples spreading across the surface of a pond, except they travel across the entire universe. The recent detection of these waves has provided us with a completely new way to observe and comprehend the workings of our cosmos. It is truly incredible to realize that these binary systems function as natural laboratories for exploring extreme physics. The conditions within them are so intense that they provide an opportunity to test the fundamental laws of nature in ways that are impossible to replicate in any laboratory on Earth. Consequently, each time we observe one of these systems, we are, in effect, peering into a unique cosmic crucible where our most advanced scientific theories are being rigorously tested. As our technology continues to improve, scientists are uncovering more and more secrets about these systems. The development of more powerful telescopes and sophisticated observation techniques allows us to look deeper into the interactions between these stars and to search for the countless neutron stars and black holes yet to be found. The discoveries that await us could very well reshape our fundamental understanding of the universe. At the very heart of these cosmic pairings, you will always find epic stories of stellar life and death. Stars that have burned brightly for millions of years engage in an intricate celestial ballet that can culminate in a magnificent explosion. This perpetual cycle serves as a powerful reminder that everything in the cosmos is interconnected and in a constant state of transformation, with neutron stars and black holes representing just one fascinating piece of this ever-expanding puzzle. Ultimately, the existence of planets within binary systems confirms that the universe is a place teeming with surprises and marvels. Every star, every planet, and every binary pair has a unique history. As our exploration continues, we are certain to learn more about how these intricate arrangements enrich the cosmos and perhaps even foster life in the most unexpected corners. The dance of binary stars is not merely cosmic choreography. It is a profound journey toward understanding our own place in the vast tapestry of existence. To truly appreciate their importance, let's explore a few specific examples found right here in our home galaxy, the Milky Way. We can start with the fascinating case of Algol, a binary system located in the constellation Perseus, which is renowned for its peculiar activity. Algol is an eclipsing binary, which means that from our vantage point, one star periodically passes in front of the other, causing a noticeable dip in its brightness. This celestial rhythm has been observed for centuries and has been instrumental in helping us unravel the nature of binary stars. The tale of Algol unfolds like a celestial play, with stars engaging in a cosmic game of hide-and-seek across the grand stage of the universe. An equally compelling illustration is the binary star system Sirius, which shines as the most luminous star in our night sky. Sirius is composed of two stellar bodies, Sirius A, a brilliant white star, and Sirius B, a white dwarf that originated as a much more massive star. The interplay between these companions has offered astronomers a priceless chance to investigate how stars mutually influence one another, helping us comprehend star formation and the ways different stellar types can coexist within a single system. Deep within the heart of the Milky Way, you can find a less famous yet equally fascinating binary system, known as an X-ray binary, with Cygnus X1 being a prime example. This particular system is made up of a supergiant star and a black hole. The stellar companion to the black hole is in a constant state of being consumed, a process that generates powerful X-ray emissions detectable from Earth. The very presence of Cygnus X1 has profoundly altered our understanding of stellar life and death, and has been instrumental in shaping our comprehension of the nature of black holes. What about binary systems that provide us with a look into the universe's ultimate destiny? Consider, for instance, binary stars that are fated to merge. When two stars in a close binary arrangement draw near enough to each other, their gravitational forces can trigger a spectacular fusion, resulting in cataclysmic phenomena like supernovae. These cosmic events are not only awe-inspiring, but are also fundamental to forging the heavy elements that constitute our bodies and the world we inhabit, meaning every glance at the sky reveals the legacy of these stellar explosions. On the subject of heavy elements, are you aware that a significant portion of the elements that form the Earth, and indeed life itself, were synthesized in the cores of stars? Binary stars have a pivotal function in this cosmic alchemy. Throughout their life cycles, massive stars can erupt as supernovae, scattering elements such as carbon and oxygen across the cosmos. These elements are indispensable for the birth of new star systems and planets, including those with the potential to harbor life, making binary stars not just a part of the universe's past, but direct contributors to our existence. The Milky Way serves as a home not only to well-known binary systems like Sirius and Algol, but also to countless millions of others. Through dedicated research and observation, astronomers have determined that approximately half of all stars in our galaxy belong to binary or multiple star systems. This realization has completely reshaped our perspective on how stars are born and how they evolve. The intricate interactions between stars in a binary partnership can steer their evolutionary paths in ways that are both surprising and profoundly complex. But how exactly do we manage to observe these binary stars across the sheer vastness of space? The solution is found in our modern technology. Sophisticated telescopes and observational techniques, including spectroscopy, empower scientists to dissect the light emitted from each star in a binary pair. By carefully analyzing this light, they can deduce crucial information about the star's chemical composition, surface temperature, and orbital motion. It is remarkable to consider that we can unlock the secrets of these stars, using light that has journeyed millions of years to finally reach us. The history of studying binary stars in the Milky Way is rich with thrilling breakthroughs, stretching from ancient astronomers who first noted the behavior of Algol to contemporary scientists examining systems like Cygnus X1. With each technological leap, we move closer to grasping the fundamental mechanics of the universe. Every binary star tells its own distinct story of creation, evolution, and in some cases, ultimate destruction, showing us how the forces of gravity and energy are woven together to form the cosmos we see. When we contemplate these systems, we begin to see that binary stars are far more than just objects in the sky. They are central figures in the grand narrative of the universe. In a sense, they serve as a cosmic mirror, reflecting the intricacy and magnificence of all that surrounds us. As our technological capabilities continue to advance, so too does our capacity to study and comprehend these stellar systems. Forthcoming space missions and next-generation telescopes hold the promise of revealing even more profound secrets about binary stars and their role in the galaxy's ongoing evolution. Ultimately, the binary stars of the Milky Way offer a captivating reminder that the universe is perpetually full of surprises.
From the immense power of supernova explosions to the creation of new elements, these systems provide deep insights into the life and death of stars, the formation of planets, and our own position within this cosmic tapestry. So, the next time you look up at the night sky, remember that among those glittering points of light, there are countless stories waiting to be told and profound mysteries ready to be solved. Exploring the fascinating world of binary star observation is like opening a gateway to a universe brimming with mysteries and potential discoveries. Binary stars are, at their core, two stars gravitationally bound in orbit around each other, and studying them has transformed our understanding of the cosmos. But how do we succeed in viewing systems that are so distant and complex? It is crucial to first grasp that stars are not simply specks of light. They are massive spheres of gas that radiate immense light and heat, and the key to studying them lies in observing their motion. As two stars circle a shared center of mass, their positions shift against the backdrop of the sky, and it is this celestial dance that astronomers are able to observe and measure. So, what are the magical instruments that make this possible? Telescopes are our primary tools for observing stars, functioning like giant eyes that peer deep into the universe. With their aid, we can capture the faint light of stars, even those located millions of light years from Earth. Yet, not all telescopes are created equal. Different types are engineered to capture various aspects of light, unveiling secrets that would otherwise stay concealed. For instance, while optical telescopes are the most familiar type, radio telescopes can detect radio waves, which represent another form of light entirely. When observing binary stars, optical telescopes enable us to perceive the brightness and sometimes even the colors of both stars, offering valuable clues about their temperature and composition. This becomes particularly revealing when one star passes in front of its companion, a phenomenon that tracking systems are designed to monitor, allowing us to gather even more detailed information. Through sophisticated techniques, astronomers are able to chart the paths of stars across vast stretches of time. You can picture it as a cosmic version of hide and seek, where one star periodically obscures its partner. By conducting numerous observations over time, we can ultimately determine the mass and size of each star in the pair. But how can you be certain that you are observing a true binary system and not merely a trick of perspective? To unravel this mystery, scientists turn to a method called spectroscopy. When starlight is directed through a prism, it separates into its constituent colors, much like a rainbow, revealing a unique spectral fingerprint for every star. Analyzing this signature allows us to identify a star's chemical makeup, its velocity, and confirm whether it is gravitationally bound to a companion. In certain cases, the orbits of binary stars cause them to eclipse one another from our vantage point. Imagine a pair of distant lighthouses. As one moves in front of the other, their combined light momentarily fades. This event, known as an eclipse, provides astronomers with an incredibly powerful analytical tool. By carefully measuring these fluctuations in brightness, we can precisely calculate the distance separating the stars and deduce crucial details about their respective sizes. So, what does all this information reveal about the cosmos? Each new insight gained from studying binary stars contributes to our broader understanding of dark matter and dark energy, the enigmatic substances that constitute the vast majority of the universe. Consider these stellar pairs as essential clues in a grand cosmic puzzle. The more pieces we collect, the more coherent our picture of reality becomes. Our technological capabilities are also progressing at a remarkable pace. Advanced space observatories, such as the James Webb Space Telescope, have utterly transformed our capacity to view the heavens. Positioned beyond the distorting effects of Earth's atmosphere, these instruments capture images of unparalleled sharpness and detail, enabling us to study binary star systems with extraordinary precision. Looking ahead, what new frontiers await in the exploration of these systems? The continued advancement of new technologies like interferometry will permit us to link multiple observatories into a single network, effectively creating one colossal telescope. This will empower us to resolve even finer details, unveiling new binary pairs that have remained hidden until now, all driven by an insatiable human curiosity to uncover the universe's secrets. Investigating binary stars is far more than a simple academic pursuit. It forges a direct link to our shared human history. A common thread of fascination with the stars connects ancient skygazers to today's scientists. This timeless quest to understand the cosmos is an endeavor that unites all of us, transcending both time and geography. But what deeper lessons can be drawn from observing these celestial dances? Every binary star system holds a unique story about its life and interactions. By examining their evolutionary cycles, we can learn a great deal about the development of entire galaxies and the birth of new stellar systems. In this sense, binary stars serve as cosmic chroniclers, and by paying attention to them, we can discover the secrets of our own universal origins. Ultimately, the observation of binary stars offers you a gateway to the infinite, allowing you to probe the very limits of the cosmos without ever leaving home. The next time you gaze up at the night sky, remind yourself that there is an immense reality beyond what your eyes can see. The perpetual dance of binary stars serves as a constant invitation to continue exploring, questioning, and, most importantly, dreaming. While binary stars are captivating in their own right, their relationship with dark energy introduces a profound layer of mystery and complexity that demands exploration. You can think of it this way. If stars are the luminous lights of a cosmic city, then dark energy is the invisible atmosphere that permeates everything, unseen but critical to the city's very structure. How then do these stellar pairings help us comprehend this elusive energy? It's crucial to first grasp that dark energy is the force believed to be driving the accelerated expansion of the universe. Picture yourself inflating a balloon. It starts expanding slowly, but the more air you force in, the faster its surface stretches. The universe's accelerating growth is analogous to this process. This is where the role of binary stars becomes truly fascinating. These systems, defined by two stars orbiting a shared center of gravity, present us with a method for measuring immense distances across space. By knowing the separation between the stars in a binary pair and their apparent brightness, astronomers can estimate the concentration of dark energy within a given expanse of the cosmos, making these systems vital beacons for charting cosmic expansion. The reason these stellar pairs are so indispensable lies in their inherent stability. In contrast to solitary stars, whose brightness and size can vary significantly, the stars within a binary system tend to exhibit more consistent properties, which in turn allows scientists to make far more accurate measurements. For instance, observing their orbital mechanics allows us to calculate their masses, and from there, their gravitational pull. Data essential for understanding how dark energy interacts with ordinary matter. Occasionally, some binary stars draw so near to one another that they merge, triggering a cataclysmic explosion we call a supernova. These monumental events not only brilliantly illuminate the cosmos, but also produce gravitational waves. These ripples in space-time, like the concentric waves from a stone tossed in a pond, carry information about the fundamental nature of the universe and, by extension, about dark energy itself. Binary stars also play a significant role in the formation of galaxies. The gravitational influence they exert can attract vast clouds of gas and dust, seeding the birth of new generations of stars and planetary systems. This cosmic cycle, in turn, affects the distribution of dark energy across the universe, positioning these stellar pairs not just as observers of cosmic history, but as active participants in its unfolding. Through meticulous observation of binary systems, we have discovered that dark energy is not spread uniformly throughout the cosmos. Instead, its distribution is uneven, which suggests its influence might fluctuate from one region of space to another. You can visualize this as a cosmic spiderweb, where certain strands are pulled tighter than others. Binary stars are the tools that help us map these tensions in the very fabric of the universe. On another front, investigating these stars has yielded incredible breakthroughs concerning dark matter, the cosmic counterpart to dark energy. By observing how binary systems affect visible matter, scientists have been able to deduce the presence of this invisible substance, which exerts a profound influence on the dynamics of the universe. As observational technologies advance, the examination of binary stars grows ever more precise, with modern telescopes and orbiting satellites providing astronomers with increasingly detailed information. With every technological leap, we are drawn nearer to solving the puzzles of dark energy and the fundamental nature of the universe itself. The relationship between binary stars and dark energy represents a vibrant and constantly developing area of research, where each new discovery gives rise to new inquiries. What further secrets might these stellar pairs hold? And how will a deeper knowledge of dark energy reshape our understanding of the cosmos's future? One thing remains clear. Binary stars are set to be a vital component in our quest for these answers. It is truly remarkable to consider that these pairs of stars, engaged in a celestial dance for millions of years, are linked not only to each other but also to the most profound questions in cosmology. They serve as characters in a grand cosmic epic, with each new chapter bringing us closer to deciphering the immense and magnificent story of the universe. So, the next time you gaze upon the night sky, remember that some of those brilliant points of light may be partners in a cosmic ballet that is helping us unlock the secrets of dark energy and, by extension, life itself. Within the limitless expanse of the cosmos, binary stars act as beacons, lighting our way toward knowledge and steering us through the exploration of the unknown. They are far more than just paired lights in the sky. They are like two performers on a cosmic stage, their movements in perfect harmony, with every turn and step affecting one another. But what kind of an effect do these stellar duos have on the creation of our galaxies? And how does their presence mold the universe as we perceive it today? To grasp this, you first need to think about how galaxies themselves are born. Picture the universe as an enormous, empty canvas, with galaxies being the strokes of a cosmic artist's brush. In this creative act, stars, and binary stars in particular, are absolutely essential. When stars come together to form binary systems, their collective gravity begins to organize the surrounding gas and dust, orchestrating a kind of gravitational symphony that can initiate the birth of new stars. Every time these stars interact, they open up fresh possibilities for other star systems to emerge, which brings up a fascinating question. Can binary stars actually help sustain a galaxy? The answer is a definitive yes. As two binary stars draw near one another, their gravitational pull can gather gas and dust from their vicinity, which in turn leads to the formation of more stars. It is as if two friends at a gathering decide to bring more guests, enriching the galaxy and adding new energy to the cosmic performance. As these binary stars continue to evolve, their impact on the galaxy grows even more captivating. Some may end their lives in supernova explosions, casting immense amounts of energy and newly forged elements out into space. Have you ever paused to think about where the elements that constitute everything we know, from our planet to our very bodies, come from? They are often born in the hearts of stars, and these explosions scatter them across the cosmos, seeding the interstellar medium for future generations of stars and planets. Furthermore, the interactions within binary systems can also result in the merging of the two stars. When this happens, a tremendous burst of energy is released that not only alters the stars involved, but can also produce a major effect on the galaxy as a whole. This merger event can establish entirely new conditions for star formation, positioning binary stars as true catalysts for change throughout the universe. Binary stars do not just shape the immediate environment of their birth. They are also capable of influencing the dynamics of galaxies on a much grander scale. For instance, their gravitational forces can shift the orbits of other stars and alter the movement of gas clouds within the galaxy, setting off a kind of domino effect. Can you envision a group of dancers whose choreography alters the tempo of the entire orchestra? This is a fitting analogy for how binary stars can sway their galactic home. Now, let's explore why binary stars are so crucial for comprehending the evolution of galaxies. Through the observation of binary systems and their interactions, astronomers can piece together the story of how galaxies take shape and change over cosmic timescales. Each binary star acts as a portal to the past, containing narratives that offer us hints about the history and transformation of our own Milky Way galaxy. What can be said about binary systems in other galaxies? It turns out these systems are by no means exclusive to the Milky Way. Distant galaxies are also filled with binary stars, each progressing through their own life cycles. Observing these stars in other galaxies is akin to peering through a temporal telescope, showing us how the universe's history is written through these stellar relationships. In examining the influence of binary stars on galactic formation, we cannot overlook the vital role of ongoing research in this area. Each revelation about binary stars can guide us toward a more profound comprehension of the universe's structure. For example, by learning how these stars impact the creation of others, we can glean insights not only into cosmic history, but also into how the universe will continue to develop far into the future. By the same token, research into binary stars contributes to our understanding of the universe's expansion. As galaxies interact and evolve over billions of years, binary stars remain a key player in this intricate cosmic dance. Grasping how these stars affect that expansion brings us one step closer to solving one of the greatest mysteries in all of cosmology. Ultimately, binary stars are far more than a simple astronomical curiosity. They are a foundational element in the history and ongoing story of every galaxy. By examining how binary stars are formed, how they merge, and the ways they affect their cosmic neighborhoods, you can develop a much clearer understanding of the universe's dynamics. In this way, every pair of binary stars doesn't just narrate its own unique tale. It also enriches our comprehension of the immense and compelling story of the cosmos itself. These stellar pairs are essentially the threads that compose the intricate fabric of the universe, linking together stories, elements, and moments into one magnificent design. Historically, binary stars have been a subject of great fascination within astronomy. But what was the very first insight that helped us realize stars don't always exist alone? Toward the close of the 18th century, the English astronomer Sir William Herschel made a revolutionary observation that fundamentally altered our view of the cosmos. As he studied the night sky, he realized that certain points of light were not single stars as they appeared, but were, in fact, pairs of stars locked in mutual orbit. And with that, the idea of binary stars came into being. This groundbreaking revelation not only dismantled the prevailing assumption that stars were exclusively solitary objects, but also initiated a completely new chapter in the field of astronomy. Following in his father's footsteps, Sir Frederick William Herschel advanced this research in the 19th century, dedicating himself to a deeper investigation of these captivating stellar duos. His careful observations led him to begin categorizing the various kinds of binary systems he encountered, and you can only imagine the thrill he must have experienced upon discovering that some of the brightest stars were actually two. As our technology became more sophisticated, our capacity to observe and comprehend these systems grew alongside it. In the 20th century, the American astronomer Robert Kraft contributed significantly to this field through his work on spectroscopic binary stars. This meant that he could move beyond just tracking their positions and instead analyze their light signatures to learn about their complex interactions. It's truly remarkable to consider that a star's light can reveal the entire story of its life and its relationship with a companion. We must also acknowledge the trailblazers who studied eclipsing binary stars. During the 18th century, the British astronomer John Goodricke made a phenomenal discovery when he observed that some stars periodically and predictably dimmed. This dimming was caused by one star passing in front of the other, a phenomenon that not only became essential for understanding binary systems, but also evolved into a method for measuring vast distances across the universe. So, the next time you gaze at the night sky, consider that the brightness you see might be a sign of an intricate cosmic dance. Beyond its scientific contributions, the concept of binary stars has also fueled the imagination of artists and writers for generations. The idea of two stars bound in an eternal celestial embrace is a powerful one that has been widely explored in poetry and literature, as a symbol of profound connection and the universal quest for companionship. In a way, these stellar pairs mirror our own human relationships, demonstrating that even within the immense scale of the universe, connection is a beautiful and vital force. In the 21st century, the introduction of space telescopes like the Hubble has completely transformed our grasp of these systems. Picture the sheer excitement among astronomers as they began to find that our galaxy hosts thousands upon thousands of binary stars, a great many of which are still waiting to be studied in detail. The analysis of these systems has also led to the identification of extraordinary events, such as supernova explosions, which frequently happen within binary star partnerships. Modern technological advancements have also given scientists the ability to measure the masses of stars in binary systems with incredible precision. This capability has been absolutely fundamental to our models of stellar evolution. By carefully tracking how these stars orbit one another, astronomers can calculate their respective masses, and from there, predict their entire life cycles. It's thrilling to think that you can determine a star's ultimate destiny simply by observing its relationship with another. Then there are the even more exotic binary systems containing neutron stars and black holes, which have captured the focus of countless researchers. The notion that a super-dense neutron star can be locked in a cosmic dance with a regular star is utterly captivating. The interplay between such celestial objects can trigger dramatic events, including stellar mergers that radiate powerful gravitational waves, discoveries that not only deepen our knowledge of the universe but also expand the limits of our imagination. Our journey to understand binary stars is also a testament to the power of international cooperation. Scientists from all over the globe have collaborated to share data and observations, proving that the study of the cosmos is a genuinely collective human endeavor. This collaborative spirit has fueled discoveries that would have been unattainable otherwise, as the astronomical community unites to decode the universe's secrets, with each breakthrough bringing us closer to the truth. Every story of discovery in the realm of binary stars serves as a powerful reminder that human curiosity is limitless. from the earliest sky gazers to today's leading scientists. The ongoing quest to comprehend our place in the universe has been an exhilarating adventure, evolving over centuries from simple naked-eye observation to advanced technologies capable of probing the darkest recesses of space. Contemplating these achievements inspires us to look toward the future. The study of binary stars is nowhere near its conclusion. New technologies and observational techniques are constantly being developed, each holding the promise of revealing more about the fundamental nature of the universe. What incredible discoveries might be waiting for us in the years ahead. The history of binary stars is a story that is always unfolding, and every new finding adds another page to the great book of astronomy, inspiring future generations to look up and wonder what else is out there. Every binary star system serves as a cosmic emissary, beckoning you to explore, to question, and to dream. The history of their study is deeply connected to our own, acting as a constant reminder that the vast universe always holds new discoveries. This captivating realm of dual stars is rich with mystery and potential, prompting us to wonder just how deeply we can comprehend the cosmos by concentrating on these compelling systems. Binary stars are far more than just paired points of light in the night sky. They are natural laboratories that provide you with the opportunity to investigate intricate cosmic phenomena. In our current age of technological progress, the instruments available for examining these systems are more advanced than ever before. This raises an exciting question. What does the future have in store for our quest to understand binary stars? Astronomical research is advancing with incredible speed. New technologies emerge daily, from optical telescopes that grant you incredibly detailed images to spectroscopic methods that unveil the chemical makeup of stars. Imagine an observatory capable of perceiving not just visible light, but also radio waves, X-rays, and other forms of radiation. Such tools dramatically broaden your understanding of binary systems and their dynamics, as combining different wavelengths can expose hidden interactions that were previously undetectable. Orbiting satellites, including the Hubble Space Telescope and the forthcoming James Webb Space Telescope, are fundamentally changing your perspective on the universe. These powerful instruments enable you to observe binary stars in previously unreachable corners of the cosmos. Can you picture having the ability to study stellar pairs in remote galaxies, far beyond our own Milky Way? Every new finding allows scientists to develop fresh theories about how galaxies form and evolve, with binary stars playing a vital part in these cosmic narratives. The future also holds the promise of even greater international cooperation in astronomical research, as telescope projects in Chile's Atacama Desert join forces with space-based observatories to share data and findings. This collaborative spirit is paving the way for breakthroughs that would be unattainable otherwise. As the global astronomical community unites to unlock the universe's secrets, each discovery brings you one step closer to the truth, while a diversity of cultural perspectives enriches every analysis. Computational astrophysics stands at the cutting edge of this research. Three-dimensional models of binary systems can simulate the intricate dynamics of these stars and forecast their future evolution, much like a video game operating under the laws of physics. With these simulations, astronomers can anticipate events like stellar mergers or supernova explosions within binary systems, making you wonder what consequences these powerful events will have for the ongoing evolution of the cosmos. Moreover, the study of binary stars is now closely linked with the search for exoplanets. Astronomers are increasingly discovering that binary systems can indeed host planets, which introduces new questions about how such worlds can form in an environment with two suns. You are left to consider whether planetary systems can maintain equilibrium around two stars, and what implications this would have for the possibility of life. Binary stars also represent a rich field for investigating dark energy and the expansion of the universe. By analyzing how these stars interact and move, you can acquire insights into the very structure of the cosmos. This exploration leads to profound questions about the nature of dark energy, the mysterious force that constitutes the majority of the universe, and what revelations might emerge from studying the connection between binary dynamics and cosmic expansion. Breakthroughs in measurement techniques are also revolutionizing the study of binary stars. For instance, interferometry methods, which permit measurements with incredible precision, are becoming more widespread. This directly enhances your ability to determine the masses of stars in these systems, a crucial factor for understanding their life cycles. More accurate measurements allow you to validate theoretical models and uncover new stellar properties. Education and public outreach are equally vital to the future of binary star research. As social media and digital platforms expand, astronomy becomes more accessible to a broader audience, allowing you to connect with scientists and participate in citizen science projects. At the same time, new developments in artificial intelligence are being applied to analyze enormous astronomical data sets, where complex algorithms can spot patterns that might elude the human eye. This collaboration between humans and machines promises to accelerate discovery in ways you can only begin to imagine. Yet, despite all these technological leaps, binary stars continue to surprise us, with each new observation sparking fresh inquiries. Human curiosity is a relentless force, and every answer only opens the door to more questions. The pursuit of knowledge about these systems is a boundless voyage filled with wonder. Looking ahead, it is crucial for you to remember that astronomy is a science in perpetual motion, and the established truths of today may be reshaped by the next generation of telescopes and research methods, leaving you to wonder what new stories the stars will tell. Since the earliest times, binary stars have sparked human curiosity. But have you ever questioned if every star you see in the night sky is truly alone? The reality is quite surprising. A great many of them are bound in binary systems, where two stars are locked in an orbital embrace, like partners in a cosmic dance. While this might sound like a celestial romance, such pairings are incredibly common throughout the vastness of the universe. You might naturally assume that most stars are solitary wanderers, much like our own sun, casting their light alone into the void. The cosmos, however, is filled with unexpected configurations. It was only in recent centuries that we discovered that stars could have companions on their journey through space. The crucial question is, how do we tell a lone star from a binary pair? The answer is found through meticulous observation, as astronomers track stellar movements and fluctuations in brightness to identify these celestial partners. A prevalent misunderstanding is that binary stars should always appear as two distinct points of light. In fact, many are so distant, or their orbits are so tight, that from our perspective on Earth, they look like a single brilliant star. This raises an intriguing question. What exactly happens when two stars exist in such close proximity? The interactions within a binary system can be extraordinarily dynamic, sometimes with one star siphoning material from its neighbor, triggering brilliant celestial events. This process, known as mass transfer, can even culminate in dramatic outcomes like supernova explosions, revealing how these relationships can be both destructive and generative in a star's life. Another common myth revolves around the presumed stability of these stellar systems. You might imagine that binary partnerships are perpetually harmonious, but that couldn't be further from the truth. The gravitational forces at play are immense and can be incredibly disruptive. In some scenarios, The stars can even collide in catastrophic events that astronomers study with intense focus. It's a stark reminder that even celestial relationships can be exceptionally volatile. There's a tendency to view binary stars as a mere cosmic novelty, but studying them has been essential for unlocking the secrets of the universe. These systems serve as natural laboratories, giving us a clearer understanding of how stars form, evolve, and ultimately meet their end. It's quite remarkable to think that these stellar pairs are helping us tackle fundamental questions about the very origins of matter and life. Within the field of cosmology, binary stars are also indispensable tools for gauging cosmic distances. By using these systems as celestial yardsticks, astronomers can more accurately calculate the distances to other objects across the universe. While some may perceive this method as overly complicated, it's actually a brilliant application of our knowledge of gravity and stellar luminosity to map the cosmos. Of course, the myths don't stop there. It's frequently claimed that binary stars are a rarity, but the truth is that over half the stars in our galaxy belong to binary or multiple star systems. This single fact fundamentally alters our perception of the universe. So, you might ask, why does the misconception that they are unusual persist? It likely stems from a general lack of public information or the way astronomy is often depicted in popular media. The discussion of binary stars is also closely linked to the phenomenon of variable stars, whose brightness appears to change over time. In a binary system, these brightness fluctuations can be caused by the star's interactions. This can result in eclipses, where one star passes in front of the other from our point of view, creating a truly spectacular celestial light show. The idea of two stars engaged in a game of hide-and-seek across the expanse of space is certainly captivating. In our culture, binary stars are often romanticized and portrayed as perfect, complementary partners navigating the darkness. This idealized image, however, doesn't capture the full picture. Relationships in space are frequently complex and turbulent, which prompts a moment of reflection on our own terrestrial connections. You can certainly see parallels between the powerful interactions of stars and the dynamics of human experience. The grandeur of the cosmos is a profound mystery, and within this magnificent theater, binary stars perform a crucial, often underappreciated, role. Their importance lies in how they help us decipher the mechanics of stars, their life cycles, and by extension, the behavior of the universe itself. If you think about what we've learned, you can envision stars as actors in a grand drama, each with a unique narrative to unfold. When we speak of binary stars, we are not just describing two suns in a shared system. It's more like observing two dancers whose movements are so perfectly coordinated that each one influences the other, creating a cosmic performance with far-reaching consequences. This interplay is essential to understanding their evolution and, therefore, the evolution of the entire cosmos. This leads to one of the most compelling questions. What can binary stars teach us that single stars cannot? Ultimately, we must move past the idea that binary stars are simply curiosities. They are, in fact, fundamental to our comprehension of the cosmos, teaching us invaluable lessons about gravity, the formation of galaxies, and even the elusive nature of dark matter and dark energy. So, the next time you gaze up at the night sky, I encourage you to remember that behind those twinkling lights are intricate stories and complex relationships waiting to be understood. The study of these celestial pairs is truly at an exciting frontier. As new technologies and collaborative research methods emerge, the boundaries of astronomy continue to expand. With their complex interactions and enduring mysteries, binary stars will undoubtedly remain a powerful source of inspiration and discovery. The ultimate question isn't just what we will find, but how these new revelations will reshape our understanding of the universe and of our own place within it. The answer is rooted in how binary stars provide a direct window into the workings of stellar physics. These systems allow us to precisely measure their masses, determine their chemical makeup, and watch how their gravitational dance influences their entire life cycle. Much like a mirror, binary systems reflect the intricate nature of the cosmos, helping us to decode its secrets with each new observation. When you look up at a star, you are observing a story that has been unfolding for millions of years. But have you ever considered that many of these stars may not be alone? Binary pairs reveal the history of their own creation, showing us how they came together in the void of space, and how their paths became forever linked. This cosmic intertwining can even shape the formation of planets, demonstrating that their influence reaches far beyond the stars themselves. In some ways, the dynamics of binary stars can be likened to a romantic relationship between two people. They are powerfully drawn to each other, yet they also transform one another in profound ways. This can set the stage for spectacular cosmic events, such as supernova explosions, where one star's evolution can lead to the brilliant demise of its companion. It's a remarkable concept that love in the cosmos could produce such magnificent consequences. Binary stars also function as essential tools for gauging the vast distances of the universe. They act as a sort of cosmic ruler, allowing us to calculate the sheer scale of the space that surrounds us. Without the information they provide, our comprehension of the universe's expansion would be significantly more limited. Every time an astronomer analyzes the light from a binary pair, they are weaving another thread that connects us all by revealing the grand structure of the cosmos. Ultimately, the pursuit of understanding binary stars is a journey into the great unknown. Each discovery raises new questions, compelling us to explore even further. What might happen if we locate more binary systems at different stages of their development? Such findings could fundamentally reshape our models of star formation and even our ideas about life in the universe. It is our own curiosity that serves as the engine driving us to explore beyond our current horizons. The importance of these stellar pairs also extends to our understanding of dark energy and the formation of galaxies. The cumulative influence of these stars on the evolution of their host galaxies helps us piece together how large-scale cosmic structures take shape and change over eons. Every gravitational interaction within a binary system can be seen as a small building block in the grand architecture of the universe. The path of research into binary stars is filled with exciting possibilities, largely because our technology is constantly improving. These advancements, from more powerful telescopes to innovative methods of analysis, allow us to observe ever finer details. Each new tool is like a beacon that illuminates the enduring mystery of these stars, leaving us in suspense and awe about the discoveries that await us in the future. We should also take a moment to consider the myths that surround binary stars. They are often given romantic or mysterious qualities that don't always align with reality. A crucial part of the scientific adventure is dismantling these misconceptions. Science offers us a story that is far richer and more complex, one that moves beyond simple wonder to a deeper level of understanding. As we conclude this journey, it is important to remember that the study of binary stars is more than just an academic exercise. It is a reflection of our own species' quest for knowledge. Each question that emerges inspires new avenues of exploration, and every answer we uncover brings us closer to understanding our own existence in this boundless universe. The story of binary stars is a narrative of connection, interaction, and evolution. It's a reminder that even though we are separated by immense distances, every star in the sky is entangled in a cosmic web that unites us all in this extraordinary journey. So, the next time you gaze at the night sky, remember that there is so much more than what your eyes can perceive. Binary stars, in their silent dance, are witnesses to the history of the universe and to our own relentless search for answers.